tree. There is no logic. Different logic అంటూ లేదు. Simply add the smaller elements tree to the greater elements tree. That is. So this is for this we have to write an algorithm with respect to count mechanism. Count mechanism means in this we need to represent the maximum number of nodes available in the tree with respect to count. That will be represented with a negative number. Why? Because this is initially the p the elements in the p I, that is represent in terms of minus count. Why? Because always the elements as this is a root, so it goes down like this. That is why it is representing the negative values. Like this. Take this example, then I will explain this one. Initially, we'll take all. Suppose if you take the 1 to 8 elements in the external exam, you will get the question like this only. Explain the weighted union with respect to one I less than or equal I less than or equal 8. Means it is 8 elements. By performing these operations 1, 2, 3, 4, 5, 6, 7, 8, 1, 3, 5, 7, 1, 5 union operations. How you build the tree? So at the initial stage, all are individual elements with the weight is one node, that is represented -1. So initially what I said, always P of I, root of I is equal to count of I. P of I means P of 1. P of 1 is count of 1. How many nodes are there? 1. Its depth is, it is simple logic. Similarly, second element also. Total 8 elements are there. Itself they are the roots at the level of 1. So that will be represented in error representation like this. 1 to 8 elements are there. 1, 2, 3 up to elements, and its weights are -1, -1, -1. That means all in 8 elements itself they are the roots. Itself they are the roots. Minus indicates itself it is the roots. And -1, that means the tree consists only one node. Minus indicates itself it is the root. 1 indicates itself it is the count of nodes available for that concerned tree. Coming to the this is the first step, 1, 2. Next I have to perform this operation 1, 2, 3, 4, 5, 6, 7, 8. By applying the union rule, so that is, so take this one union of 1, 2. 1, 2 become the children of 1. That automatically the depth goes to 2, -2. Here the minus indicates itself it is the parent node. 2 indicates the total number of count of nodes available in concerned tree. So 1, suppose for this 1, it has total 2 elements 1, 2. Minus indicates it is the parent node. Second node, so it is the children of 1 parent, like 3, 4. 3 is the parent node, 4 is the children, like represents. This is the level 2. This is already explained. Level 1. This is the level 2. So next out of the basic operation, suppose I have to merge these two. What is going on like this? Suppose if I want to merge this is added to here. 1 become the parent, 3 become the cell. Up to now 3 is the parent. Once we perform the union operation of 1, 3, so 3 become the children of 1. So at the time 1 is become the parent node with the 4 elements 1, 2, 3, 4. This is general representation. 1, 2, 3, 4. So this is the one. It has total 4 elements. Here minus indicates itself it is the parent node. Itself it is the parent node. 2 is the children of 1. 3 children of 1. 4 children of 3. So this is the one tree. This is the one more tree. So for this tree, this is the union of 5, 7. So that is means 7, 8 tree is added to the 5, 6. So automatically 5 is the parent. So that represents it has total 4 elements with the root. 6 is the children of 5. 7 is the children of 5. 8 children of 7. That is, this is. After that, again I have to perform the union of 1 comma. Union of 1 comma. ఇక్కడ నుంచి important అమ్మా. Union of 1 comma 5. So that means union of 1 comma 5 means here two subtrees are have same level. Automatically this is added to this. That means up to now the 5 is the parent node. How we will identify here 5 minus 4 is there. Minus indicates itself it is a parent node. Whenever we perform the union operation on that one, so 5 become the children of 1. So automatically its values change. So it has 4 nodes, it has 4 nodes. Total 8 nodes are available. So it is the depth of total count of this node. And this minus 1 indicates, 1 is the parent node. The 5 becomes children of 1. That is, this is the waiting node. This is the waiting node. So మన జనరల్ గా ఎక్కడ ఇచ్చేస్తున్నామంటే by arranging the data structures in the memory. So link the one node to the another node. So in that way we have to use these disjoint unions. So this is the waiting union. By performing the elements like you will get the question like this. Consider the tree created a waiting union on the sequence of 1 less than or equal to 8. On that I have to perform the 1, 2, 3, 4, 5, 6, 7, 8 and 1, 3, 5, 7 and 1, 5. Build the tree. With respect to array representation, we need to write all these steps. Level 1, level 2, level 3, level 4. And it is also named as boundings. Boundings means it gives the maximum boundary of worst case bounding. Which is the worst case bounding means there is no technique for this one. We have to commonly you perform the union operation on the elements. You will get like this. This is the union operation. Any doubts from union? Asrekar? Jntuh? Jntuh, are you there? Srekar?
Yes, sir.
ఏం దగ్గుతున్నావు?
ఏం లేదు సార్.
ఇప్పుడు యూనియన్స్ అనేది క్లారిటీ ఉందా స్పీకర్?
సార్.
Okay, right. Next we will go to the collapsing find. This is the collapsing find means. Srekar, I will ask the doubts to you. You listen carefully. This concept is very simple and very important. Collapsing find is nothing but we have to identify the corresponding parent node in the tree. Suppose we are using the browser Google. Suppose if you want search any words in that one, it will take some time. Next time if you search same word, it comes immediately. Okay, immediate means already once you search, data will be stored in the buffers. Nothing but cache memory. So automatically the searching time will be reduced. So on that concept, the collapsing point will be. So once we search any element, that element is linked to the parent. Is a collapsing point. Check this one. This is the basic algorithm. I will explain later. First I will go through the example. So suppose if you take this tree, just I built. So that will be represent like this. This is the total 8 elements are there. Just we build. So that is 1 is the count with 8. And it is minus 1 itself, it is the parent node, and 2 is the children of 1, that is 3 is the children of 1, 4, the 4th root is 3, 5th root is 1, like this. This is the given graph. For on that we have to apply the collapsing rule for the find operation. Suppose I want to search an element 8. How many steps it will require? If I want find an element, how many steps required? Suppose by applying this algorithm, initially it is R, it is the I. Suppose if I want set the element I, it is I, this is the I, 8. That is I is equal to 8. By substituting this one, I is equal to 8 means then I will go to this loop. PR, parent of R. R, what is R value? 8. Parent of 8 is 7. 7 greater than 0 or not? 7 greater than 0. Right. Automatically, what is the next step? What is the next step? Again, loop goes to here. Same loop will be repeated. R is equal to P of R. Initially, what is R value? 7. Like, that is R value. So that means, what is that means? That means from 8, it is the searching element I. So it identifies the parent 7. So now the loop at 7. Next, R is equal to 7. Parent of P of R, P of 7 is equal to R is equal to 5. Then it goes to the like here. That means this is the finding operation. First, my intention is search the element 8. So its parent is 7. Again, it is not a parent node. Why? Because it is a positive value. That is why it is not a parent value, parent root. Again, it goes to the identify the parent of 7, goes to the 5. It is the 5. Again, second, same process repeat. R is equal to 1. That is P of 1 is equal to 1. So then, it goes to the parent of 1. In the next step, when parent of 1 comes to there, again in the next loop, R is equal to minus 1. So initially we will check P of R. One root is minus 1. The condition is fail. So that is the final root of 8. Final root of 8 is, it is the 1. So this is the searching mechanism. In the collapsing find, we reset the links like this. Check this one. In this, it is very important collapsing find. In the element replacing, parent replacing. So once we find this one is the parent root. For this, I have to reset the link. That means initially 8 is available here. That will be relinked to the this one. This is the resetting of link. It is the resetting of link. That means initially the root of 8 is 7. After collapsing, the root of 8 is 1. So in the initial step, at simple find operation, so how 8 to 7, 7 to 6, 6 to 5, 5 to 1, this is the 4 steps that are required. But once you apply the collapsing, so it is directly connected to 8. So whenever, the next time, if you want to search the 8, directly it will identify the 8 as in the single class. It is a benefit of collapsing. So in the first step, the root of 8 is 7. In the second step, the root of 8 is 1. Same process. Again, so 8 is collapsed. Next, you have to collapse the 7. Next, I have to collapse the 5, recollapse. So in this step, in the second step, the root of 7 also collapsed. That is 7. Initial root is 5. This is the initial root. After executing this collapsing find, 7 is directly connected to 1. That is the 1. So due to this, so whenever in further, if you want to set the 7, directly it sets the 7 from the 1 only. No need to go to the roots of others. No need to set any parent nodes. Directly it will check the children node only. That is the benefit of this one. So next, by applying this algorithm, same recursively, next I have to reset this fifth link also. So initially it is the parent link. Now it becomes the children link. It is a children link. So the one is replaced by one means reset the link. Reset the link. So this is the collapsing find. So main benefit ఏంటంటే చూడండి సరే. Suppose if you want to search any words in the tree or any words in the array, initially it will take some time to search that word. So after applying the collapsing algorithm, suppose same word if you want to search in the same database, immediately you can able to identify it. Why? Because it is directly linked to the parent node. It is directly. So example at this one, sorry, this is initially 8 is connected to here. It will take 1, 2, 3 links. In this two are parent links, one link. In the second search, this is directly connected to one. This is the benefit of collapsing. This is the mainly benefit. Suppose if you want to apply the find operation on 8 elements, it will take total 24 moves to search the all elements in that array. 3 parent link. This is the parent link. This is the parent link. This is the parent link. And remaining go ups and searching elements. Total 24 moves are required for the simple find what you have previously used. But by applying the collapsing find, only it requires 13 moves only. Only it requires 30 moves. 3 going ups, 3 resetting links. This is for this application 1, 2, 3. 7 remaining finds. Total 7 finds, 7 elements are there. 7 are connected to the one, so 7 finds are there. So totally 13 moves are enough to search the element in next time. So initial time it requires total 24 moves. In the for next time it requires only 13 moves to find the element in the given tree. This is the collapsing find. Srekar, Nada, Srekar, Chandu. You are also not responding, Chandu. Srekar.
సార్
ఏమి రెస్పాండ్ కావట్లేదు చెప్పేది వినపట్లేదా?
వినిపిస్తుంది సార్.
ఇప్పుడు కొలాప్సింగ్ ఫైండ్ కానీ వెయిటెడ్ యూనియన్ బెనిఫిట్స్ ఏంటి చెప్పు చందు, నీకు తెలిసింది నెంబర్ వర్డ్స్ అయిపోయింది. సెకండ్ యూనిట్ ఫస్ట్ హాఫ్ ఇస్ కంప్లీటెడ్. చందు, శేఖర్
సార్ ఉన్నాను సార్.
వాట్ డూ యూ అండర్స్టాండ్? అసలు నీకేమర్థమైంది యూనియన్ వెయిటెడ్ యూనియన్ వల్ల కానీ కొలాప్సింగ్ ఫైండ్ అల్గోరిథం వల్ల కానీ వాట్ డూ యూ గెట్?
సార్ ఇప్పుడు కొలాప్సింగ్ అల్గోరిథం చెప్పమంటారా?
చెప్పు. అసలు వాట్ ఇస్ యూజ్ ఆఫ్ కొలాప్సింగ్ ఫైండ్ అల్గోరిథం?
అంటే ఎలిమినేటింగ్ సార్. ఎలిమినేటింగ్ the unnecessary or
don't use that type of words. Suppose if you want search any word in the Google, in the first if you search the same word, it will take much more time. If same word you will search in the next time, it will take very less time. Yes or no?
Yes sir.
Why? Because by applying the collapsing find algorithm, it is very important. It will be used in the binary search or searching element in the our machine also. ఎలా అంటే సపోజ్ మీకు చెప్పాను, సపోజ్ ఇఫ్ యూ టేక్ దిస్ గ్రాఫ్, సపోజ్ ద ట్రీ consists only 8 elements. If you use the simple find, that means in the first searching it will take 24 moves to find the element in the tree. If you search the same element again after applying the collapsing rule, it will require only 13 movements only. By applying the resetting, it means collapsing the links, it is eliminating the links. That means, in other words, unnecessary links that are directly connected to the main root. Suppose here the 8 is connected to 7. After applying the collapsing, 8 is connected to here. So initially, if you want to search the 8, 1, 5, 7, 8. But now, if you search the same element from 1 directly, you can able to get is the collapsing point. That will be implemented by using this algorithm. This is the tracing of that one. So if same algorithm, they will ask in the external exam or mid exam, we need to write this tracing also. ఇప్పుడు చెప్పు శ్రీకర్.
సార్
చెప్పు.
లేదు సార్, క్లియర్.
One word is enough to.
లేదు సార్, కావాల్సిన ఎలిమెంట్ ఏదైతే ఉంటుందో అది ఫైండ్ అవుట్ చేయడం కోసం మనము కొన్ని ఎలిమెంట్స్ ని ఎలిమినేట్ చేస్తాం సార్.
There is no elimination in this graph. Remember that one.
Okay,
you have
sir.
resetting the links. Resetting the link means initially 8 is connected to 7, right?
Yes, sir.
In the collapsing, we remove this connection link which is directly connected to 8. Initially 7 is connected to here. In the second step, it is directly connected to like this. Suppose in further, if you want to search the same element, so no need to go to the tree. So from 1 directly you can able to get the 7 and 8 elements. Yes?
సో అంటే లింక్స్ ని చేంజ్ చేస్తున్నాం సార్.
That is, here one word is there, sir. Resetting links.
Resetting the link.
Remaining marvel elements. Suppose if 7 is there, one find is enough. 8, one find is enough. 2, one find is enough. For 4, 2 finds required, 2 times. So 1 it need to search the 3. After that, from 3, 2 required. So find operation, order of n square. That is like. So after the relinking, suppose if you want to find 4 is required, Srekar.
Yes, sir.
What will we do? So initially this one will be disconnected, this is directly connected to the parent. This is a relinking. So that means at the time 1, 2, 3 is not a parent link. Now it is a parent link, right? After
yes, sir.
After resetting, it is not a parent link, it is general link. So at the time, if you want to set the fourth, one click is enough to set that element. Yes,
yes sir.
Any doubts from this one?
No, sir, it's clear.
So first, the second unit, first half is completed. Second unit, first half. So in this, what I explained to you, just very simple things. So what is the set? I'm going to revise this one. What is the set? Set is nothing but set of distinct element with a unique feature. That means there is no common element in the sets. On that, we can able to perform the different type of operations. Make a set. That means make a set collection of elements. That is create a combine all elements. Union, combine the sets or individual elements, and find set the elements in the array. These are the different operations. On that, we can able to perform only 2 operations. That one is union and find operation in this unit. Thus, that is the. So we have to take the design sets. It is a very important question. Design sets means if the sets have no common elements. That means S1, S2, S3, 3 sets are there. There is no common elements in between the sets in the design sets. If any common element is there, it is not a design sets. No common elements. So generally the sets are represented in the 3 format like this. So generally first element treated as a root of this one. For this one is the root, remaining 3 are the children. For second, true is the tree, remaining 2 are the children. Third, 3 is the root, remaining 2 are the children. This is the general tree representation of the sets. This is a linked list representation. So generally in the data structures implementation or pointers implementation, so we have to use linked lists. For that, for the tree will be represented like this. S1, link is pointed. So that means this address consists of the total details of the set 1. This address consists total details of set 2. This one consists total details of the set like this. This is the linked list representation of sets. So this is a different operation. This is array representation of the sets. So it is easy to understand and easy to represent. Suppose S1 is there. It has total 4 elements 1, 7, 8, 9. So the tree representation 1, its parent is -1. That means itself it represents the parent node. And 7, 8, 9 are children. 7 is the children of 1. Means parent 8, parent its parent is 1, like this is. Next 2 -1. That means 2 is the parent node. 3 is the parent node, like this. This is the array representation of the sets. So this is the basic representation of sets or disjoint sets. So on that, you have to perform union operation. Union operation is nothing but combine the two sets or two elements. That means combination of all elements from set 1 and set 2 is the union of 1. That will be represented like this. You may perform the S1 union or S2 or S2 union or S1. So like this. So according to the union operation, it will be represented like this. So that will be represented in array representation like this. This is S1 union S2 or S2 union S1. But both represent the same elements. Only change in the its root position. From S1, second set is assigned to the first set. Then 1 becomes the parent node. The first set is assigned to the second set. Is the 2 is the parent. That is a small difference. This is the adding tree. Remaining all things are the same. Whatever 1 is added to 2, 2 is added to. But there is no change in the elements in the either tree 1 or tree 2 or S1 union S2 or S2 union S1. The combined finally will get the combined element or total elements are two sets. This is the find operation. In the set operation, generally, if you want find any element, find of means it simply return the corresponding set element, corresponding set name. But it is not a correct way to represent the one. You need to identify the corresponding root of that one. That is the finding operation that will be implemented in the collapsing find. This is a simple union operation. So simple union means the J element is assigned to the this one. This is a simple union operation. So this is like this. What we have implemented previously. Simple union means we are adding the all elements to this one. Simple find is nothing but you to find the suppose take find of 6. 6 root is 3. 6 root is 3. Parent of 3. Parent of 3 is -1. This is the -1. So according to the rule of array representation, if -1 is represented itself, it is the parent root. So whenever if we represent find of 6, it returns the 3 only. That means 6. Its root is 3. When it goes to 3, its parent is -1. Though there is no further, so the 6 parent is 3 only. It will return. So in the simple find operation, it returns the only main parent root of the given tree. This is a simple find operation. There is no logic. So this is the analysis of this one. Suppose if n elements are there, if you by using these operations 1 to 2, 2, 3, 3, 1 to 2, that means 1 is connected to 2 is connected to 3, 3 is connected to 4 like this. So you have to calculate you have to represent the time complexity for union. For each operation, it required only one unit of time. For n-1 operations, it required n operations. For finding operations, for each operation, it required one element. If you want to search the n finds, that means we need to search the n elements. It required order of n square. That means like order of n square means one is calculating 2. One is calculating 2. 2 is 3. So for to find the 1, required 1 clock. If you want to find 2, need to find 1 and 2. If you want to search 3, that means 1, 2, 2, 2, 2, 3, like this. For n, like the sum of 1 plus 2 plus up to n minus 1. Sum of n number is nothing but n into n plus 1 by 2, nothing but order of n square is the complexity for the n operations. So this is a weighted. Generally, the simple find algorithm and simple union algorithm is not enough to represent our elements in the sets. To improve the performance, we need to change the unions. That is the weighting rule. Weighting rule means based on the length, and representation, the tree depth will be changed. The tree depth. Suppose if small trees are there, that will be merged with the big trees to reduce the representation. To easy to find out. To improve the weight like this. Suppose if you want to, here n elements are there. Here n elements are there. If you want such an element, you need to set the individual one by one set of elements. So after building the set, if you want to set element, first you go to the parent node. From one click, it will find the corresponding element. This is the benefit of union. So depends on the weight. You have to add the elements for this. So while merging that means while performing union operation to individual set, we have to merge the two individual subsets. PA and PJ. I comma J are the two different sets. P of I is equal to P of J. So here we have to follow the one common rule. The tree which has very lower number of nodes, that will be merged with the bigger tree. That means the nodes which has the greater elements. That is. So that is the rule. So suppose if you take n elements, 8 elements, if you perform the operations 1, 2, 3, 4 like this, these steps are involved. So initially the depth of the tree represents -1. That means each element itself is the root element. That means the parent node. So that is error representation for this one, like this. By merging the my union operation 1, 2, 3, 4, 5, 6, 7, 8, we will get the trees like this. All are individual trees. And here -2 represents the tree consists 2 elements. Minus indicates the corresponding element represented the parent node. This is that one. By merging the 1, 3 and 5, 7. So here we only represent the parent nodes also. Parent nodes only. Here 1 is the one parent node and 3 is one more parent node. We are merging this one. That is why either the tree which has a root 3 is merged with 3 or 1 is merged with 1. 3 like either left or right. So here 3 is merged with 1. The corresponding trees will build like this. This is at level 3. That means level 1, level 2, level 3. Next, 2 subtrees are there. Again, I have to match 1, 5. So this question is represented in the textbook or questions itself. Based on this union operation, we have to build that tree. So yesterday we got one circular. The mid exams conducted in your home only, but the questions not given directly by using the Bloom's level only. That means that the question general we need to write the answers. That means that answers are not available in our textbook. But these basic details are help to solve that problem.
Sir, that is for 4th years they mentioned, no, sir.
Emma?
It is for 4th years they have mentioned, no, sir.
Not 3rd and 4th. For both sections. మీరు కొద్దిగా ఛాలెంజింగ్గా తీసుకోవాలి ఇప్పుడు, ఎందుకంటే వీఆర్ గివెన్ ద క్వశ్చన్స్ ఆన్ బ్లూమ్స్ లెవెల్. దట్ మీన్స్ ఫాలో సమ్ పర్టికులర్ స్టాండర్డ్. Generally we will give the questions. If you got the concept at the table, you can able to write the answer. Otherwise, not. This is the collapsing rule. So this collapsing find weighted unit, which is very simple. Collapsing rule. It is generally used in the searching concept. So after building the tree, find, if you use the simple find, it required 24 moves. So after applying the collapsing fine, it requires only 13 moves. So in the further, whenever you want to set the same element 8, it requires only 13 moves. That means you saved 11 movements, 11 units of time. So that is my benefit of collapsing. So today I will send this material to you. You will go through it and prepare. And in the next class I will start your 4th unit. That is the grading method. Any doubts that you will ask? Yes, Nikar.
సార్
ఏ డౌట్స్ అడగండి అయ్యా.
ప్రస్తుతానికి ఏం లేవు సార్.
చదవలేదా?
లేదు సార్, ఇప్పుడు ఏం లేవు అంటున్నాను.
ఇప్పుడు సెకండ్ యూనిట్ ఫస్ట్ హాఫ్ అనేది వెరీ సింపుల్ కాన్సెప్ట్.
సెట్స్ గురించి కదా సార్, మొత్తం
ఆ?
సెట్స్ గురించి కదా సార్.
ఓన్లీ సెట్స్ అండ్ యూనియన్ అండ్ ఫైండ్ ఆపరేషన్ ఓన్లీ. లాజిక్ అనేది వెరీ సింపుల్ ఉంది. డీటెయిల్ మెటీరియల్ ఐ విల్ సెండ్ టు యూ. యూ విల్ ప్రిపేర్ ఇట్ అండ్ యూ విల్ ఆస్క్ ఎనీ డౌట్స్ యూ హ్యావ్.
సార్ అది మిడ్స్లో ఎలాంటి క్వశ్చన్స్ అడుగుతారో, ఐ మీన్ అట్లీస్ట్ దాని మోడల్ గా ఏమైనా కొన్ని క్వశ్చన్స్ చెప్పగలుగుతారా?
నేను ఈరోజు ఒక క్వశ్చన్ మీకు మీ సిఆర్కి వాట్సాప్ చేస్తాను. విల్ ట్రై.
ఓకే సార్, షూర్.
సపోజ్ ఇలా ఉండొచ్చు అని ఒక క్వశ్చన్ నేను షేర్ చేస్తాను.
ఓకే సార్.
ఓకే
ఓకే సార్.
సపోజ్ ఎలా అంటే I will send it. Once you will go through the material, definitely you can able to attempt the question, but I can't sure you can able to solve or not.
Try చేస్తాం.